Good morning, everybody. Welcome to the Low Carbon Vehicle Partnership and APC's LCA webinar series. This is our final session today, and the theme is Building an Environmentally Conscious Industry. My name is Gloria Esposito, and I'm Head of Projects at the Low Carbon Vehicle Partnership, and I'm moderating today with my colleague Philippa Alden from the APC. We've got a range of expert speakers today, and what we're going to be doing is really discussing the themes that we've covered over the entire week and looking to see how we can really build a sustainable automotive industry and taking into account some of the things that we've looked at across the vehicle life cycle in terms of vehicle production, in use and end of life. So with me today I have Dr. Andre Sereno. He's from UK Fire's Industrial Strategy at the University of Cambridge. Emmet McNamee from the UN Principles of Responsible Investment. Owen Griffiths from Oakdean Hollands, and Inga Mills from the Department of Transport. Over to you, Philippa.
Thanks, Gloria. So like any event, we always have a little bit of housekeeping. So I'm just going to share a housekeeping slide with you. So we encourage you all to fill in your questions and pose questions to the panelists throughout the session. So just please add your questions into the Q&A box at the bottom of your screen. We also have a chat function. So again, please use that to have conversations amongst yourselves during the session. So we just want to remind you that if you want to have an open discussion, make sure you select on the top that all attendees can see your post. We will be recording today's webinar, so if you have to go off for another meeting, don't worry, you'll be able to catch some of the speakers later. Be social, either on LinkedIn or Twitter or any other social media channel using the hashtag LCA Week. We've already had some great response and some feedback on that using that hashtag across those sites. And we really will want to capture your feedback so that that informs future activities that we do. And finally, at the end of the session, we will ask you to fill in a short survey. It should only take around 2 minutes, which hopefully captures any sort of feedback that you've got on the session and the speakers and prompts us for potential future events. So really hope you enjoy the session. I'm sure we will do. Back to you, Gloria.
Thank you very much. Well, I'm delighted to introduce our keynote speaker today, Dr. Andre Sereno. He's a Senior Research Associate at UK Fire's Industrial Strategy, Resource and Efficiency at the University of Cambridge. So Andre, over to you for your presentation, please.
Thank you very much, Gloria, for your kind introduction. A minor correction, I since changed my job title. I'm now a university lecturer in Cambridge. Thank you so much for your introduction, Gloria, and thank you so much for this invitation to give this talk. It's really a pleasure and really nice to be able to share some of the work we are doing. And the work I wanted to share with you today is about a report we produced a few months ago called Absolute Zero. And the main motive for doing this report was a decision taken last summer precisely by Prime Minister Theresa May. In one of her last days in office last summer, she did a very tiny but crucial change to the Climate Change Act in the UK. So instead of the target for emission reductions in the UK being a reduction of 80% from 1990 levels, now the target is 100% from 1990 levels. And although this might seem a relatively small change, it has huge consequences. And I'm not sure everybody in Parliament, when they approved these, were aware of the severity of these consequences and how challenging this change is going to be. So putting the target on 100% emission savings by 2050 put the UK in the forefront of the greatest global economies in terms of the most ambitious climate target. I guess only Finland has a more ambitious target than the UK, hoping to cut emissions completely by 2035. But the real problem, in our view, is that although the target is set in terms of net carbon dioxide emissions, actually the net zero emissions is likely to mean an absolute zero target. And the main reason for that is that carbon removal technologies necessarily always take more energy than emitting carbon. And we will likely to have a shortage of clean electricity supply in the future. And even if we think about all the mitigation options, such as planting trees, for example, even if we were able to double the amount of forest in the UK, that would only offset our emissions for 2 years, and that effect would cease to exist after that period of time. So in a way, with the previous target of 80% emissions reduction, everybody and every single business in the country thought that the most difficult bits to decarbonize could always fit in the 20% of emissions that we could remain after 2050. But now with the 100% emission cut, we really have an agenda, and we really need to think how to deliver that. One of the other reasons that led us to do this report is our concern regarding what we believe is the reality of the pace of technology implementation. So this graph shows us the amount of time that it took for different energy technologies here to first being invented and demonstrated, and that being deployed commercially before they start to growing at pace. And we are talking about a time scale of decades. And if we realize that we are now in July 2020, 2050 is only 29.5 years from now. So we are running short of time to deploy still non-commercially available technologies to sequester carbon dioxide at scale. So we need to think about other options using current technology that could lead us to deliver that target in 29.5 years' time. So as a result, we expect that there will be a gap in 29.5 years' time between the amount of clean energy that we'll be able to supply and the demand for energy to supply our needs. And this is represented here in these graphs. So on the left-hand side, we have a projection of what could be the amount of non-emitting electricity generation capacity in the UK if we keep increasing and deploying solar and wind energy at the same pace as we have been over the last few years. And on the right-hand side, in this bar, we have the projected demand for electricity in 2050. And we realize that there is a huge gap, a gap of about half of our total energy demand in about 30 years' time. Of course, filling this gap is going to be really challenging. One of the reasons is, of course, we can have these breakthrough technologies or negative carbon technologies, and if they exist, that would be fantastic. But even if they are deployed, it's difficult to imagine that they will be able to fill such a large gap that accounts for emissions that would be associated with fulfilling half of our energy needs in 30 years' time. So we need to think about other options, other strategies that we need to follow to reduce our energy demand, and so that it might become more likely that we are able to demand to supply our future energy supply without emissions. And with that in mind, we produced this report, The Absolute Zero, which is available freely online. It was in this report, we wanted to launch a public discussion of what to mean delivering zero emissions with current technology, proven technology that's already commercially available with incremental change. But of course, that will also require some changes in our industry and also in our lifetime. This report has had far greater impact than we could have imagined and has generated a great momentum for change. It was even debated for an entire afternoon in the House of Lords earlier this year. So we hope that with this document, we can start this discussion of what really needs to happen in 29 and a half years' time. So I'm going now to discuss in more detail for the different sectors of the economy, and particularly for transport, what this could mean delivering zero emissions with existing technologies. So right now we have here in this graph, so all this bar below the black line represents all the amount of energy that we are currently using fossil fuels. And of course, because we won't be allowed to burn fossil fuels in 2050 because that would be against the law, we'll have to electrify all our energy users. So this represents transforming all this burning of fossil fuels into electricity. But of course, we're likely to have a shortage of zero carbon electricity to supply our future demand. So we will need to find ways of reducing our demand for electricity in the future. And that we estimate should be around 60% of our projected needs. So we need to reduce those 40% remaining. And of course, this is going to be particularly hard for transport because most of the energy uses in transport are based on fossil fuels. Looking into industry, of course, we are able to electrify most of our energy demand in the country. And we could reduce our demand for electricity even after doing that by implementing a set of strategies that already exist. We can think about the impact of extending the life of the products that we use so that we don't have to produce them that often, and with that reducing our energy demand in producing the materials used to manufacture those goods and also the energy required to assemble them. Also, we can think about reducing over-design and product size. And this is particularly important, especially for vehicles, for cars, and for buildings. We are currently over-designing buildings. We can use much less concrete and steel than we actually need for the same built space. And in doing that, of course, we can reduce substantially all the industrial energy demand to satisfy our needs. And of course, small contributions can also come from continuing progress in energy efficiency. So if we are able to keep pace in following our best available technologies, avoiding overuse, packaging is one of the examples where perhaps we have opportunities for progress there, and of course reducing scrap, which is basically energy that's used to produce materials that never make into a product because they are scrapped in the production process. So of course, if we can avoid that waste, we will be saving energy across the board. And again, that's particularly important in the case of the automotive industry, where lots of metal scrap is generated. Regarding buildings, buildings is also a challenging sector to decarbonize because most of our energy use in buildings is for space heating and cooling, most heating in this country. We already have all the technologies available to electrify all these energy uses that take place in buildings. We know how to cook with electricity, how to heat and cool with electricity, so that's not a problem. The problem is that even if we electrify all our energy uses in buildings, we'll have a much higher demand for electricity than we have today, and we are likely not to have enough zero carbon electricity to supply that demand if everything goes electric. So we need to find ways of reducing our demand for electricity. And we can do that mostly by deploying the best available technologies in heating, especially using heat pumps, which are tremendously more efficient than other electrical heating systems. And that could deliver a substantial amount of energy savings. Continuing progress in the efficiency of energy use in appliances, which we expect, and it's currently also with the largest consumers of electricity in buildings. And of course, building insulation for existing buildings and keep improving the standards for new construction so that we are able to reduce our heating and cooling energy demands. That's essential if we are able to, if we are willing to reduce substantially our electricity use in buildings today. Of course, other small things we can do, for example, keep improving lighting efficiency, although that delivers a smaller effect than the previous examples I discussed. And transport. Transport is one of the most challenging sectors to deliver zero emissions. And the main reason for that is that when we look here into this graph on the left-hand side, we see that we have a tiny amount of energy used in transport, which is electricity, for electric trains. Everything else is based on burning fossil fuels. So we have to electrify all that, and that's challenging. Especially for a few sectors, as I'm going to explain later. But even if we electrify all road transport and the remaining rail that's not electric, we'll still need to find ways of reducing the energy demand. And we have technologies to do that. If we electrify all cars, because we'll be able to benefit from regenerative braking, we might save a substantial amount of electricity from that. Regarding freight transport, we believe we could save up to 30% of current energy demand for freight in the UK with logistical improvements, managing better the way we deliver freight. There is a great potential to save energy by reducing the average weight of cars on the road and vehicles in general. Mode switch might be also a very helpful strategy. Of course, we know that trains are more efficient than cars. So if we travel more by train than by car, we might also contribute to further energy savings. And of course, more savings can come from reducing drag and tire friction. In more detail, regarding transport, of course, we know that for long distance traveling, most energy is used to overcome air resistance. So the key to reducing energy demand is to reduce top speeds and drag by using long and thin vehicles. And this is a train, right? Trains are thus the more efficient mode of transport for long distance traveling. And a full electric train can move people using 40 times less energy per passenger than a single-use car. So there is a huge opportunity there to reduce energy easily by shifting, by mode shift, using more rail transport. Another opportunity is the reduction of weight in passenger cars. If we are willing to reduce our energy use in transport by 40%, so to 60% of our projected needs, we'll need to either reduce the weight of cars or reduce the car mileage in an equivalent proportion. And it's a combination of those two that we need to explore. So either a reduction on weight, on the design of the cars, or a change in our lifestyle and the amount of car use that we want to deliver. There are, however, 4 key activities very, very challenging to decarbonize and without substitutes, some of them around transport. One of which is shipping. Shipping is challenging to decarbonize because of it's difficult to find an alternative fuel. Even if we imagine the use of battery electric ships, they couldn't cover long distances because they wouldn't have enough autonomy for very long distance. Hydrogen for fuel cells in ships, again, that hydrogen needs to be produced from zero carbon sources, and that's the main constraint there. We could think about other alternative fuels such as ammonia, although that burning ammonia generates a powerful air pollutant, which is the nitrous oxides. We can think, of course, about nuclear propulsion for shipping, although currently we almost use that technology only in military vessels, and that would present other challenges as well. Another one is, of course, aviation. We can imagine electric planes. They exist. They could eventually be deployed at scale, but they could only be used for very short distances because of autonomy. And the main critical limitation for that is the weight of battery storage. We can, again, think about alternatives to jet fuel if they are based on electricity, such as hydrogen, for example. We, again, have a shortage of zero carbon electricity that might limit that. And if they are based on biofuels and biomass, we need to make sure that doesn't compete with food production. And we can't forget that the global population is still increasing and is going to keep increasing until 2050. Another challenging sector is chemicals and cement. And these two are special because they generate CO2 not necessarily as the result of burning a fossil fuel, but as a result of the chemical reactions required to produce them. So in the case of chemicals, most of these happens for fertilizers. So we need to explore ways of being more efficient in the way we use fertilizers to reduce emissions there. Regarding cement, of course, we can explore opportunities to use less cement, avoiding over-design in buildings. And finally, the last challenging sector to decarbonize is, of course, livestock. We all know that lamb and beef are much more emitting than other types of food, but we'll still have to eat other types of food even if we give up on lamb and beef. And there are emissions associated with those other foods as well. So we need to find alternatives there, and we need to find ways of perhaps compensating those emissions somehow. This graph, which is in the report, I'm not going to detail about it, but details for each sector the kind of change that we foresee happening with current technology. But the main message I wanted to end up with is that change is on the way. Change is already happening. And we know that if we remember a few months ago, the court ruling about the third Heathrow's runway, which was cancelled because it was deemed to be incompatible with the Climate Change Act. So this tells us that these and possible other future similar court actions will have a substantial financial impact across all businesses and all industrial sectors. So we need to start thinking about how to reach zero emissions in a sensible way, and we hope to start making strategic, sensible recommendations to achieve that target in 29 and a half years' time. Thank you very much.
Thanks, Andre. That was fascinating. And what's really interesting there is that, you know, much of the technology is already there, and it's actually just how we apply it and use it and put some intelligence into that. So it's really interesting. Right, I'm delighted to say we've got a couple of questions for you. I believe we're going to go to Greg Archer first. Greg, are you with us? Just wait for you to hopefully be unmuted by the team.
Good morning, everybody. Good morning, Andre. Thank you for your presentation, but very interesting. Am I right in understanding that the way that you calculated the gap was by looking at the historic growth in renewable technology? And if so, isn't that a very conservative assumption, given that we now know that wind and solar are maturing technologies? The costs of deployment are coming down very, very fast. Therefore, with any traditional S-curve, we could now expect very rapid take-up in the next few years. And indeed, the electricity sector itself has said it plans to fully decarbonise by 2040. But alongside that, I have to say that I agree very much with your overarching message, which is that we need to recognise that there will not be an infinite amount of renewable energy available to decarbonise every sector of the economy. And therefore, actually, it's extremely important that we use the renewables which are available as efficiently as possible. And for example, if we were to fully electrify road transport using batteries or direct power, then T&E's calculations are that would require about 1,400 terawatt hours of energy. On the other hand, if you were to use synthetic fuels, that would take nearly 5,800 terawatt hours of renewable energy to create that fuel. Substantially, you know, what was that, nearly 4 times, 3.5 times more. So we really do need to recognise the limitations on the renewables available and make use of them. Thank you.
Greg, thank you. Thank you very much for your question. And I hope you are right, and I hope our estimates of deployment of renewable energy are conservative, because that would mean we'll have more in the future than we are foreseeing now. However, when we look into the past, into the long past, we have seen that there was never the case when technologies grew faster than 1% a year. Of course, things may be different in the future. Hopefully there will, but we need to be prepared for the case when that's not possible. So we need to be able to act and to plan strategically to avoid that gap in the future. If those technologies are deployed at a faster pace, that would be fantastic. But in any case, it's prudent to be prepared to reach our energy demand in the future. And we have, in most cases, the technologies already to do that. So we should be doing that already.
Thanks, Andre. I've got another question now for you from Jeremy Simpson. Would you like to ask your question, Jeremy?
Good morning. Thank you, Andre. It was a very interesting presentation. I really enjoyed it, and obviously we've got big gaps to overcome there. On your about gains from the weight reduction of vehicles, I just wondered if you could expand on that a little bit more. I know that weight is very significant for combustion engine vehicles, but with regenerative braking, rolling resistance and aerodynamics, it becomes much more significant because that can't be recovered. So I didn't know quite how you. I know also that there are some limits to regeneration. So I just wondered if you could explain a bit more about that.
Absolutely. Thank you very much, Jeremy, for your question. We know electric drivetrains are much more efficient than combustion engines. And we know that, and electric cars, if we are able to electrify the entire fleet, we could save up to 70% of energy demand by doing that. However, electric cars are also heavier because of batteries. And on top of that, people are willing, over the last 10 years or so, we see those trends. People are increasingly preferring SUVs and heavier cars than city lighter cars. And those two effects combined are offsetting, limiting the fantastic potential benefits and energy savings that we could get from the electrification of the car fleet. So we need to explore that option. We need to find ways of reducing the weight of cars so that we are able to maximize and exploit the full potential benefits of electric cars. If we were able to reduce the average weight of cars by 30 or 40%, we could reduce the energy demand of a car for the same mileage by around 40 or 50%. So that's a fantastic opportunity that's out there. Unfortunately, currently, most transport policies are focused on incentivizing the shift to electric cars, which is good, but it's not enough. And hopefully in the future, we'll have policies incentivizing the use of lighter cars and incentivizing the reduction of weight of cars, because that would be the only way of exploiting the benefits of electrifying the fleet.
Andre, I think a lot more to do. Delighted Andre is going to stay with us and join the panel later. So moving on swiftly to our next speaker, I'm delighted to introduce Owen Griffiths, who's Head of Circular Economy Strategy at Oakdean Hollins.
Thank you very much. Yeah, I'm from Oakdean Hollins. Oakdean Hollins is a circular economy consultancy. We've been in evaluation and evidence-based building for 25 years, and looking at industrial symbiosis, reporting on sort of sustainability and a range of different services for public clients, private clients and trade associations. I think the unique angle that we have is that we're a heavily technical based circular economy organisation as opposed to being quite managerial or strategic, although my title suggests otherwise. We're involved in a number of different organisations, and so I was asked today to sort of talk about more of the broad shifts in communications that we're seeing around life cycle analysis, reporting on sustainability and carbon, and what we think is going to be coming down the line. I think, as Andre really pointed out completely rightly, that we have this big issue of sort of continually wanting to have a standard of living that is as it is at the moment, if not better, and that should be shared around the world. Yet we have this significant challenge of being in need of decoupling well-being and economic activity with resource use and environmental pressures. And so what we've been looking at trying to do is helping organisations that sort of turn that concept into action. And while Andre was rather focused on the energy side of things, we see that as a topic that is getting a lot of coverage and a lot of time and activity and traction. Whereas where we're focusing is on the other 45% of the emissions being created, which is the products in life and in circulation and embodied carbon within them. And within that 45%, we can see that things like designing for whole life cycles and designing for circularity have an opportunity to really reduce the impact on the environment. but there are numerous different challenges to really increasing that circularity. And so I'm just going to briefly cover off some of the ways that we can start talking about it. Traditionally, what we've seen is that organizations that really want to make shifts towards being more sustainable have been recording the impact of the products that they're putting on the market at a product level, with materials and energy being considered at the point of production and direct inputs and energy. That shift has moved into more of a life cycle thinking when talking about life cycle analysis, and considering not just where the materials and energy come from and their embodied carbon, but also the value stream down the value stream from where they've been acquired. That in itself causes challenges with transparency and also the commercial sensitivities of sharing data. And then upstream, the complexity of gaining data about how a product is used, how long it's used, and what's done with it at the end of life. This makes recording a life cycle of a product incredibly tricky. And it also lends itself to being quite subjective. So we see that often it's quite clear that businesses that would like to put an LCA out define the frame as being one that is of specifically preferable to their products. And so when we start seeing methodologies like the SBTI, Science-Based Targets Initiative, where there's this intention to record impact at an objective level, so we can create some comparisons, we see that that's getting some uptake and preferable to what is quite a subjective activity of LCAs often. But what we are seeing in terms of the product side of things is that with SBTI being very objective, we're also seeing a rise in circular economy metrics that are aiming to prioritize businesses and products based on the resource use. And the purpose of which is to try and suggest that you can be objective in your decision making when you are procuring materials and prioritizing secondary raw materials over primary raw materials because they're reduced carbon impact. The CTI tool was developed by WBCSD, the World Business Council for Sustainable Development, and is basically an overarching assessment of how resources are used within a product or an organization. Circulytics was developed by the Ellen MacArthur Foundation to provide a level of ranking for how suitable your business is for circularity. And Sustainable Development Goals, I'm sure many of you are aware, again, it's a broad range of sustainability activities. But they're all somewhat focused on less tangible elements. And so we found that all of these were, well, we found that when we were coming to sort of communicate these to organizations that were looking at making real traction within their organizations to shift to increased sustainability or circularity or reduced carbon, they didn't cut the mustard, unlike SBTI, which is a carbon focused. So when the International Resource Panel did a study of the global study of emissions through life of products and interventions that could be applied through the life of a product to increase the value, we were quite pleased with the approach that was taken, because the primary focus was on value being something that wasn't primarily carbon or economic. It was a combination of both. And they looked at value based on the material offset, embodied material, embodied emissions, process energy, process emissions, and also cost and social angles as well. They did this at a national level, but what was clear was that when we started communicating this to policymakers in the G7 and organizations large global organizations looking to get traction for increased sustainability of the organization or increased circularity of the through life interventions that they might put in place for their products, it got a lot more traction because there was a combination of an economic driver and a carbon driver. And what we've seen is that this at a board level has really led to organizations trying to consider how they can put in interventions like remanufacturing or refurbishment or repair that would lead to increased value being gained. What you've got here in terms of the sort of the differences, what you can see is that what they're doing is saying that this is the whole life of the product. Remanufacturing provides an intervention which provides a full life to the product, and you can have multiple lives. In automotive, there are discussions about 3 to 7 lives. I've heard in the electronic sector it can be 7 to 12 lives. So what we're getting is this opportunity for those resources that are pulled out of the ground, very carbon intensive with high embodied emissions, interventions through life can tackle the 45% of emissions created from the consumption of materials to produce products. And so what we found worked really well when we were talking about applying this at an organizational level was to differentiate what interventions could be taken. And we've seen that Canada Canada was leading on the G7 research around this topic, and it has decided that it's going to create a value retention strategy for the country. And they're differentiating between product value retention and remanufacturing, reuse, refurbishment and repair, and material value retention processes like recycling. And what's quite important is that we do differentiate between product value retention and material value retention, because quite often when organizations are looking at through life interventions to increase circularity, recycling is the first point of focus. And actually, in many cases, recycling provides the worst of the best interventions. What we have done, I've wanted just to lay out a couple of examples where we've seen what we're calling advanced retention technologies. And these advanced retention technologies are where organizations are providing at a product level or a material level interventions that have significant impact on the value that is being retained. I think a well-known organization to APC is Autocraft. Previously a member of a council that we run called the European Remanufacturing Council. Autocraft are not alone in their expertise in engine remanufacturing, but well recognized globally for the innovative approach and also forward-thinking way that they keep engines in life for longer. They've got an interesting model as well, which should be replicated in other companies and is replicated already in other sectors, which is the feedback loop to OEMs to improve the design of products for increased circularity, increased product value retention, which means that the interventions put in place actually reduce. You don't need to remanufacture an engine as regularly, but it provides an easier way of doing it, or maybe a less intensive way of remanufacturing later in life. Secondly, Volvo. Volvo have been very vocal about their sustainability agenda, and more recently they have decided to employ a value retention strategy within the organization. Still at its very early stages, what they want to do is fundamentally have a value retention strategy and value retention metrics underpinning decision making. And a slightly different angle here is SKF. They're a ball bearing company providing a different business model, which is one we are seeing becoming more regularly discussed, but very rarely applied effectively, which is about servitization. We've often hear about Rolls-Royce power by the hour, and rarely we hear about other examples of that, other than in the lighting space, potentially with Philips. SKF are looking to employ a pay per cycle or a pay per revolution activity.
Got 1 minute, Owen.
Sorry.
1 minute. One more minute.
Oh, sorry. Okay. Yeah, and then in the material value retention space, we have Umicore that are applying advanced interventions with regard to increasing the yields of recycling, but they're also investing in recycling technologies for targeting specific metals that are not just the bulk materials, the incredibly high value materials, but also the critical materials. Apple are providing advanced disassembly technology, which means that the components that are pulled out can go through further technologies and recycling that is very targeted. And in the UK, we've got Hypermag, which is again a really targeted recycling process focusing on magnets. So I'm just going to very briefly touch on the last 4 points are what we see coming in the pipeline of adjustments and changes to the environment. We see the European Commission is reviewing waste shipment regulations, which means that they will be, we expect that they will be suggesting that facilities that intervene at a high level for circular processes will be given reduced administrative burden. We see a shift from weight to value-based targets. Examples of this can be where we can see increased requirements for recycled content. For example, EV batteries requiring a certain amount of recycled content is expected to come in the next EV battery directive, in the battery directive, excuse me. We know that DEFRA are going to be rolling out a waste prevention program soon, and clearly any advanced retention technologies at a product level would be prevention of waste, and any secondary raw material that's produced through advanced material value retention would also be diverting from waste. And finally, with everything that's happened with COVID, we can see, and this has come out of the World Economic Forum, that there is a big shift for organizations considering local resilient solutions for their service offering, and that's where we see that there may be an opportunity or a greater intention for local product value interventions, which can offer a real carbon saving as well. Okay, thank you.
Thank you very much, Owen. Great overview of those issues regarding circular economy. I'm very pleased to introduce our next speaker now. This is Emmett McNamee, from Senior Analyst at the Principles of Responsible Investment. Emmett, it's over to you for your presentation.
Thanks a lot, Gloria. I'll just share my screen now as well, if I can find it. Okay. So, thanks, it's great to be here. I'm going to talk about something a little bit different. I'm going to talk about responsible investment, its rise, what's driving it, how this is playing out in ways that are relevant to low carbon vehicles, and some of the opportunities that all of this creates for companies along the life cycle. But to start with, just to be clear what we're talking about, responsible investment, sustainable finance, green finance, these terms are all thrown around quite a lot. But they're essentially talking about the same thing: investors looking beyond traditional financial metrics to consider how environmental, social, and governance, or ESG factors, affect the financial health of individual companies and also the economy as a whole. And so I work for the Principles for Responsible Investment, and our role is to help investors to do that, to improve their ESG approach. We were started by the UN about 15 years ago. We're based in London, but we're a global membership organization, so we have signatories around the world. And I suppose the interest in responsible investment as an approach can be seen apart from the increase in PRI's membership over the last few years. So if you see from the beginning, it's moved from quite a niche view to very much a mainstream approach. So we have today over 3,000 signatories. Collectively, they manage about 100 trillion in assets. So we estimate that to be about half of the institutional capital in the world. So for every $2 of institutional capital out there, one of them is managed by a PRI signatory. Certainly wouldn't claim that all of these are, long-term responsible investors. That's not what the PRI is about, but it does reflect an increasing expectation that investors will start living up to the green claims that they're making. Now, I don't want to simplify this because there are many things that's driven this increase, but one of the key drivers has been an explosion in policy instruments and regulations in this space. So you can see in the last 15 years, there is an increasing pace, and that pace increases today. The number of instruments, they're increasing in quantity, but they're also increasing in quality. They're becoming increasingly technical, and they're requiring investors and the companies that they invest in to take a much more sophisticated approach to specific environmental and social issues. Two specific examples of this, which you may or may not be familiar with. We have the Task Force on Climate-Related Financial Disclosure. This requires investors and companies as well to assess and disclose the approach to climate risk taken by their portfolio companies, or for companies, the climate risk in their operations. The UK has been one of the first countries to take steps to making this mandatory in advance of COP26 next year, and we can see this is likely to become the de facto global standard. At the EU level, there's also the EU taxonomy, and this will soon come into force next year, and it will require investors to disclose the extent to which the companies that they're invested in are aligned with a net zero trajectory by 2050. And so the effect of this in both cases is that investors are increasingly looking at their portfolios and saying, how can I invest in more green assets? And how can I improve the sustainability of my existing assets? And how this is playing out in practice is that investors are increasingly collaborating with one another to improve the practices and the sustainability of the companies that they're invested in. And so the biggest example that we have of this is this initiative called Climate Action 100+. And this is a group of over 450 investors targeting 160 of the biggest emitters in the world, which includes several automakers, and encouraging them to take action on climate change. And so it's been around for a few years, it's grown a lot, and the key expectations that they have today in 2020 for companies is that these companies need to commit to net zero by 2050 and disclose a strategy for how they're going to achieve that commitment. They need to align their lobbying practices with that commitment, how they speak with policymakers, and also the lobbying practices of any trade associations that they're a member of. And they also have to disclose against the TCFD recommendations, which I already mentioned. So investors, climate change is probably the #1 focus, but there is also a great interest in social issues among investors, and in particular, social issues that are related to the transition to a net zero economy. And so I thought I'd mention this one as potentially relevant to this audience. There's a collaborative engagement around the responsible sourcing of cobalt. I've put the investor expectations on the slide, but the group is also looking at how the COVID-19 crisis will affect the responsible sourcing of cobalt, and it will affect local communities and what companies can do to support them. I think one important point to make here is that investors are keen to take a holistic approach. It's not really, it's not just about, you know, avoiding reputational harm or risk avoidance. It's also about risk mitigation. And so, for example, one company has recently cut artisanal and small-scale mines from their supply chains because of the increased human rights risks that are attached with those kinds of mines and the difficulty of monitoring them. But investors are actually expressing concern about this because cutting those kinds of mines from the supply chains can have devastating economic effects for local populations, particularly in the Democratic Republic of Congo. And so it's not enough to just step away from these kinds of problems. Investors and the companies that they invest in have to take an active role in actually solving these problems. From everything I've said, it might sound that responsible investors are a bit of a headache and that you actually want to stay as far away from them as possible. But I would say that for companies that are committed to sustainable principles, for companies that have a role to play in the future net zero economy, there are a number of benefits to having these kinds of investors on board. For one, they tend to be long-term shareholders and much more engaged than like traditional investors. So it's possible for companies to actually build a relationship with their investors and have much more informed discussions. These investors are also much more likely to be patient, less likely to demand immediate returns, and to give the company space to pursue a long-term vision. And they're also less likely to sell in a downturn like we've seen recently. And the recent crisis has also shown that these investors have been prepared to give companies space to protect their other stakeholders, to protect their employees. Like these are not the ones that you see in the news demanding that dividends continue to be paid even while employees are being laid off and furloughed. In terms of access to capital, it's difficult to overstate the extent of the hunger for sustainable assets among the investment community right now, and that's only going to increase with regulations like the taxonomy that actually have a scientific basis for what constitutes a sustainable asset. And so companies in the space or expanding into the space should easily be able to access financing to expand their operations. And finally, in terms of support for progressive policy reforms, I guess there are two aspects to this. One is they're actually lobbying the entrenched emission-heavy companies to change their lobbying practice and remove one of the big barriers to effective climate change regulation. But there's a broader point, and I'll finish on this slide, is that there's increasing appreciation among the investment community and among financial sector policymakers that you can't green the financial system without also greening the underlying economy. And so you can introduce regulations like TCFD, like the taxonomy, but if you're not changing the behaviors of the underlying economy, it's very difficult for investors to be sustainable in any way. And so among investors, there is increasing support for policy reforms that would put industry on a net zero trajectory. And in this context, we've commissioned research into the priority policy areas for the UK government to take, and also the ways that UK-based investors can support this transition. And I won't go into each of these in detail, but I won't go into any of these in detail, but I'm happy to take any questions you have on them. I would just like to point out that transport is top of this list. So I'll stop there. Hope you were listening, and happy to take any questions.
I'd like to ask all the panelists to please come back on our virtual stage. We're now going to have some questions from our audience. So first of all, just to kick off, Alex, you have a question. Would you like to raise that, and perhaps for Andre?
Yes, for Andre. I enjoyed your talk very much. Well, I enjoyed them all. Thank you very much. I was just thinking, has anyone examined the the scenario of everybody giving up the right to individual personal transport. And at a stroke, you don't have to worry about small little vehicles with heavy batteries running around, which are very inefficient, as you pointed out. I realize that there are massive political and social complications in trying to sell this to people. But to me, it seems to me inevitable. It's a bit like the right to bear arms in the States. It's an anachronism. It's not going to see us through life in the future unless we give up that. Has anyone done any modeling? Does it add up?
Thank you, Alex. That's a really, really nice question and really thought-provoking one. I have never came across of any assessment of that kind. And I suspect any option like that would cause necessarily a massive disruption. And it would be very, very difficult to convince everybody to give up on individual transport. What we know is that delivering zero emissions will cause some disruption, but I think our challenge is to be creative in finding ways of minimizing that disruption as much as possible. And of course, that would help a lot if we didn't have any individual transport, but I'm not sure that would be the option that would minimize the amount of disruption felt by everybody. And hopefully, exploring all the ways, as all of the panelists also mentioned in their talks, we can minimize disruption and still deliver those zero emissions. That's my hope.
Thank you.
I think next we welcome back a previous panelist, Frances Waugh. Hi, Frances.
Hello. Hi. Now I asked, the second, right, okay. I asked two questions and I've got the direction to ask the second one, right? Okay, so this is very like a personal one. So I've looked seriously at buying an electric car, but I'm too mean to spend all the money on a car when the range that I'm looking at, they don't go very far on a single charge. And if a manufacturer told me that I would be able to upgrade the battery in a few years' time, or that it would be possible if I was selling it on in a few years' time, I'd be much more likely to do it. And that seems to fit very well with the ideas about keeping products in use for longer that have been mooted today. And I wonder if anyone knows if that's actually a model that anyone's proposing, so I can go and buy my car.
Owen, do you want to come back on that one, Frances?
I think that problem that you're having, Francis, is a very common problem. I'm finding exactly the same thing. I live in Aylesbury, and being able to travel around here, I can walk everywhere in the city, but to go and visit people, I often won't have an infrastructure. So I think that your problem is not unusual. I might lean on economics here and suggest that if more and more people are seeing that issue, OEMs will start responding. I think if you're living in urban environments, you're given a really nice range of options. You have got public transport, if you choose to use it or not. You have Zipcar and sort of leasing models, or servitization models, which can provide an alternative. But for those people in rural locations, there isn't a solution which is necessarily sustainable, renewable, which provide that. I think it's only a matter of time before someone does, whether it's an OEM or whether it's an intermediary body. I think that in terms of the through life product life extension piece, I think you're entirely right. We see more and more organizations having predictive maintenance built into products that they're putting onto the market. And so for organizations that have predictive maintenance on the batteries and that can recall them before there are major problems, or if they can foresee that it's coming to a period in its life where some adjustments or refinement, refurbishment need to be taken, can withdraw it and give you a replacement, or there's some sort of arrangement there. I think that that would be a really smart way of doing it. I can't really pull on any bulletproof examples of who's doing it at the moment in the automotive sector, but there are smart ways that we can see that happening in the electronics sector and in the white goods space. So Andre or Emmett can provide an automotive example.
Thank you very much, Owen. I just have one last question before we wrap up today. It's on the topical subject of carbon pricing, and it's always raised as an important mechanism in order to shift both, society in accordance with better practices and reducing greenhouse gas emissions. So maybe a question for Emmett, what he sees the role of carbon pricing in helping really businesses to move forward in terms of reducing their greenhouse gas emissions.
Sure, I can answer this very briefly. I think carbon pricing is a hugely favoured tool, certainly among investors, to price carbon risk and to encourage the internalization of the externality of carbon emissions. There's wide support, certainly among the investor community, to bring in a strong carbon price. I think the difficulty is primarily a political one, in that it tends to mobilize every possible across industries, and it's just been found that it's often more politically feasible to bring in sector-specific regulations, such as the phase-out of ICE engines, rather than introducing a carbon price that cuts across the board. But I think public attitudes are obviously shifting, and you've seen some of the big oil majors increasingly state their support for a carbon price now. It's not really at the level that we accompanying that carbon to get rid of a lot of the supporting environmental regulation, but it is a sign of how much the conversation has shifted when you have the likes of these massive oil majors supporting the introduction of something resembling a robust carbon price.
Thank you. Andre, maybe you can finish off, seeing that you highlighted the great challenges that we have to face. Can we use smart pricing as a measure to sort of generate more changes?
I agree that pricing is usually a great strategy to nudge behavior, and perhaps we'll need more of that targeted to specific actions and policies that may be able to deliver a big impact. If I may, just to wrap up a few thoughts from all the presentations from my fellow panelists. If I may, Gloria, I don't.
Yes, of course. Please do.
At this stage, I was really struck by the all of you spotting the point of the problem of battery production for electric cars, and that's a really important issue, because if we electrify the entire fleet, there is a huge potential benefit of doing that, but we are not exploiting it. Not exploiting it because electric cars are heavier, because our preferences when it comes to buy a new car are also changing. We want a heavier car. But on top of that, there is the problem of battery production. These batteries are made of lithium and cobalt, and these critical metals are only produced on very few sites on the globe. Sites such as the Democratic Republic of Congo, which unfortunately is not at the forefront in terms of working conditions and environmental protection. And there is also a very important problem regarding not only not the amount of those materials that we are able to extract, but at what pace we are able to produce those critical metals. And that might limit the amount of, or the speed at which we are able to produce batteries and electrify the fleet. And that's often a very important issue that's overlooked.
Thank you very much, Andre. Really important point, and hopefully something that the Transport for Department might take into account in the TDP. All our panelists today, Andre, Emmett, Owen and Inga, thank you so much for coming and giving some really interesting presentations. We've really enjoyed them today, so thanks again.
Yeah, and actually those points you made, Andre, were covered somewhat in our sessions on Tuesday and Thursday, actually. So if any of the audiences would want to hear more about that, please feel free to go to our websites and catch up on some of those. Thank you to the audience. You've been fantastic. There's been lots of chat going on today, and some links to different case studies, so we really appreciate that. Free to contact either Gloria or myself post this event, and we want to hear your feedback and your comments so that we can look at future engagement on this topic. There's a lot more to do, as we've heard from everybody today. And I also want to point you towards the Low CVP conference, which is next week on the 15th of July, looking at reset and driving the green economy. And also to remind you to fill in our short survey at the end of this session. We really appreciate your feedback. But let's please keep the discussion going, and please use the hashtag LCA Week. We will pick up with all of you afterwards on those topics, because we really feel this is an important part, and the UK has a real opportunity to lead on some of these aspects and drive the agenda. So thank you very much for your time, and I hope to meet many of you at a future, probably physical event. But for now, stay safe and stay well. Thank you.